Hey everyone, welcome. And today I will be walking you through this enterprise styled network I built here in Cisco Packet Tracer. Now today we would not just be walking through, we would actually be testing and trying to break this network just to test for redundancy and security especially. So on our network here, we have four sites. So we have the headquarters HQ here, we have a data center over here, we have branch one, and we also have branch two, all interconnected via our carrier router using eBGP, so that's external BGP, and we also have a connection to the internet over here. Okay, so just a quick breakdown of the topology. So each site runs their own BGP. So each site is an autonomous system. So we have HQ as 6 autonomous system 65001. We have branch 1 as 003. We have branch 2 as 004, and also the data center as 002 here. So and each site runs OSPF internally. And if we look closely, we can see, the HQ router or the HQ site is the most complex of them all. Okay, so if we take a closer look at our headquarter here, we can see we have two DHCP servers for backup DHCP services, since it supplies IP address and IP address configuration, across multiple branches. We want to set up redundancy for that. We also have our core switches as well with redundancy using HSRP setup as well for gateway redundancy, and we have 7 VLANs across just this singular network with VLAN 70 being our guest Wi-Fi. And also if we have a look at the data center, we have web server, we have a DNS server, we have two web servers as well, one for general web services and one for internal tooling, and we have two firewalls running in parallel for security and also to kind of protect our network from the guests, right? So we have guest network here, we want to prevent our guests from reaching our internal web servers. Okay, so the first thing we would be testing is redundancy. Now, on our HQ network, the main DHCP server is on this IP address 172.16.60.2, and the backup DHCP server is 172.16.60.6. So both are being relayed via our core switches. We have the IP airport address and we'll be advertising both, right? So if we check through our MOP here real quick, anywhere we have IP airport address across the network, so anywhere DHCP server is or DHCP service is needed across the network, both of this IP address would be provided, just for redundancy. So if this one fails, the other one would kick in. And we can see that on every single interface that needs an IP address from the headquarters, we are linking both IP addresses. So yeah, that's just that. So let's ensure both of them are turned on, just to make sure we are on the safe side. So we have DHCP and the backup also on as well. So now let's request an IP address. Okay, so let's go to IP configuration. So it's currently static. Let's switch to DHCP. Nice. So we see DHCP request successful, and our device is able to get DHCP IP address configuration from the DHCP server. So if we check here, we have our engineering team in the .10 network, and this guy is able to get an IP address within that network. But let's check who is serving, which DHCP server was used for this. So let's do that using IP config slash all. Nice. So we can see it got an IP address of .6, but then the DHCP server is 172.16.60.2, which is our main DHCP server here. If we check this network we have here, it's the same thing, or this is the server that provided, the DHCP or IP configs to the device. So now let's see what happens when we switch off our DHCP, our main DHCP server. So let's turn this off, right? And then what do you think, what do we think is going to happen when this device tries to request an IP address again? So let's do that real quick. So let's go over to static and then let's switch to DHCP again. Nice. We still get an IP address, and if we check, or let's see if we check, we still have an IP address still within the .10 network, right? But let's see which DHCP server, provided the service. So now the DHCP server has switched to .6. So initially we had this, which was .2, but now when we turned off the main DHCP server, it switched over to the .6 server we have over here, and then we can see that here as well. So that basically is how we, ensure redundancy works, especially in, high availability or a multi-site network like this. We don't want our DHCP server to ever go down without having like a backup. Okay, so the next thing we'll be testing on our network is HSRP failover for load balancing. Now, HSRP has been configured per VLAN, and I'll just show you real quick, right? All right, so if we look at this, we can see each VLAN has been assigned different priority on this particular switch. So if you see VLAN 10 here as an higher priority, VLAN 30 as an higher priority, and VLAN 50 also has an higher priority, but they all share a single virtual IP address. This is the default gateway the end device will be pointing at, but each switch has a different IP address. So there's the actual IP address configured on the switch, and then there's a virtual IP that they both share in case any of them goes down. So if we check on core switch 2, okay, let's just check here as well. Yeah. All right, so since VLAN 20 has higher priority, we can see it is active, while those with lower priority are on standby, and this is on the core switch 2. If we check core switch 1, we have VLAN 10, active, while VLAN 20 is on standby. Since we have, some VLANs have higher priority on, different switches differently, what happens when we take down a switch completely? So let's take this switch down. Or first of all, from one of the devices, right? Let's try to ping the loop back on our carrier network and see if that works. So let's do ping 1.1.1.7, which is our loop back on the carrier over here. And we can see, the ping works successfully, and 0% loss, that's 100% success. And we got a reply, 4 times. So let's take down this switch, right? Let's take down the switch. Okay, we can see we are completely taking down, this side of the network, right? So let's just take note of that, and let's give it a second to reload. It's reloading. Let's just skip through. Okay, no, and we can see our switch is back to normal. We have no running configuration. Let's test if we can still ping our loopback address on the carrier. So it might take a second to, kind of figure out, how traffic will move across the network. But let's just give it a second. So ARP will do its thing. Okay, so we got a reply now, but let's check again. So, it takes time to figure out, how to navigate through the network since one of the switch is down, but now we should get, clean replies if we try it again. Okay, good. So now we can see, we were able to successfully get replies from our loopback address, provided this was completely shut down. Now let's actually check switch 2 and see what happened now that switch 1 is completely shut down. All right, now we can see every single interface or every single port here is active, so nobody is on standby because the other this other switch has been completely shut down. So it's very important to note that this now becomes active for everybody. It handles traffic across the entire VLANs or across the network. Okay, so over at the data center, I have set up some form of security to prevent unwanted traffic. And one of such unwanted traffic being, guest networks, right? We don't want the guest network to have access to our web servers. We want them to be able to access the internet over here, which is fine, but we don't want them to be able to, peer into our internal tooling. And that has been set up using ACLs on the firewall from this like inbound traffic coming into the network. So let's test that real quick. In our engineering department, let's try to reach our web server. So this web server has a domain name of novatech.com. So let's try to reach that. Novatech.com. Hit enter and let's wait for that to load up. Great. So we can see our internal web server. So we have web server 01. It has an IP address of 3.3.3.1. Status is operational, and we can access some like internal resources, of course. It's empty, but we can see all of this. Let's test our guest access to the data center and see if it can reach our web servers, right? So let's do this and let's go to novatech.com, hit enter, and yeah, if we hold on a second, we can already see this page is just blank, right? No matter how many times we hit go, we don't see anything. And we can also test that using our simulation mode. Let's do that real quick. So using this, let's hit go and let's see what happens, right? So this is our packet starting over at the device. You can see moving over to the switch, down to the access switch. It moves over to the core, moves to the router, and now it has found its way to the carrier, over here to the DC router, and then let's see what happens when it gets to the firewall. Yeah, we can see the traffic gets blocked the moment it gets to the firewall, which means it's not allowing it to just keep going down the network. Okay, so let's check the ACL rules that were configured here. So let's do enter, and let's do show running config. So let's just keep all the way to access control over here. Very good. So this is external to DMZ. So that's from our external network coming into our DMZ. So basically we've set up a DMZ. This data center is basically a demilitarized zone setup, right? So we say, okay, from the external network coming to the DMZ, we check if the IP address is within this network and it gets denied, right? So we want to say once this is coming, trying to access any of our network on the DMZ, just make sure you deny that traffic, right? Same thing. So this is our headquarter guest network. This is branch one's guest network, and this is branch two guest network. They all get denied and the rest gets permitted. Let's also test access to the internet. What's the IP address here? Or the loop back. So we have 100, 100, 100, 100. So our guest network must be able to reach the internet, right? That is very important. 100, 100, 100, 100. And we can see we have a reply. So we want our guests to only be able to access the internet, but not our web server, which is this guy here. Okay, we can see our guest device can access the internet, but not our internal web servers. Okay, just to see how powerful our BGP is and how our routers have learned the entire network or learned how to map through the entire network. Let's just check our shoe IP route on our headquarters, right? Shoe IP route. And we should be able to see a very huge table, right? Not too big, but moderately big, and it has learned a lot of addresses using BGP, right? So this is the loopback for itself, and then these are the loopbacks for the routers across the network. And then we have 3, 5, and 0 network. So 3 and 5 and 8 rather, there's our data center, and it has lent it through BGP, which is the B we see here. We have the connected and local networks, which is .1 and .10, and then we have the 172 local networks as well. So yeah, that is a quick demo of the network. So we tested DHCP service redundancy, tested failover, HSRP, failover. We also tested, security across the network or across our data center, and also we saw how BGP interconnectivity works. All right, so if you're interested in checking out this project further, I'll be adding the link to this GitHub project in the description, so you can check out some of the topologies, you can check out some of the key documentations I'm not able to go over in this video, and maybe in another video I would actually walk through how to set up everything from scratch, right? But you can go over this. I have the documentation, and most importantly, I have the configs, right? So from the branch 1, branch 2, to the data center, to the HQ, the web the HTML files I have for our the web servers, and also the carrier and the internet, right? So if you want any of these configurations, feel free to come over here, check them, read through them, try to configure them yourselves, and let me know if you have any problem with it. I've also added the packet tracer file for this project, so feel free to download, feel free to test, and let me know what you think about it. If you enjoyed this video, give it a thumbs up, and I will see you in the next one.